Okay, stat students, this is the very last new lesson, new topic for your class and for 2020. All right, I'm going to do another video, talk about what we're going to be doing after this. So let's get through this one and then I'll take care of that one. All right, does memory train help? So this is the mean difference. So this is basically a matched pairs. We have one individual with two different measurements or two different pieces of data by that individual. So it says suppose 32 seniors were randomly selected. So there we go. We got a random to try both memory strategies. Each student calculated the difference in the number of words, strategy 2 minus strategy 1, just like we did in class. The mean of the differences was 1.5, and the standard deviation of the differences is 2.7. Do these data give convincing evidence that strategy 2 improves memory at the alpha equals 0.05 significance level? All right, so I wrote it down first of all. So we've got the mean difference. The true mean difference of words from strategy 2 to strategy 1. So our statistic in this case is going to be X bar difference. Remember that difference is a subscript equals 1.5. Our significance level, alpha equals 0.05. And a hypothesis. So the mean difference equals 0, or the mean difference in this case, because it's 2 minus 1, is going to be greater than 0. All right. So do people remember more words using strategy 2 versus strategy 1? So we have our procedures, one sample t-test. So we're doing our 4-step process still here. Our state, we got that done. Our plan, one sample t-test for mean difference. And we check our conditions. Well, like we said, I underlined it, so it is random. Sample of 32 students. All right. Now, in this case, the 10%, we say the 10%, this is one of those cases where 10%, we can say, yeah, it's less than 10% of all students. We could possibly do this, but in this case, those are all, each student is independent of each other. Ooh. All right, there we go. There's my independent, not very good. All right. And this is normal because our value of n is equal to 32, which is greater than or equal to 30. So by the central limit theorem. All right. So our conditions are all met. So let's check them all off. We're all good. All right. So now we can do our do part. All right. So in this case, our mean is the mean difference equals 0. Standard deviation. So we take S of the difference. And this is where we divide by n because this is a one sample. All right. When we have a 2 sample, we do the square root of s squared over n1 plus s squared over n2. But if we're doing it for the 1 sample, we're going to divide by n. So this is going to be 2.7 divided by the square root of 32, which equals 0.477. All right, so if you do that work on your calculator, you get 0.477. So our general formula, our test statistic equals our statistic minus the null divided by the standard error. So standard square root of n, the standard deviation. All right, so our picture in this case, draw it out. 1 sample, we've got 0 here, 1.5 down here, and we're shading in this part down here because we're talking about more than 1.5, 1.5 or more. All right, so we shade that in. Specific formula then, T equals the X bar difference minus mu difference divided by that same standard deviation. All right. So in this case, t equals 1.5 minus 0 divided by 0.477, which equals 3.14. Hey, look at that, pi. All right, so our test statistic, t equals 3.14. And our p-value then, so in this case, I would do, like I told you a bunch of times, I would use my calculator to find it right away, to find that p-value. And so if you do that, you'll find out that p-value is 0.001. All right, so, all right, we did our state. True mean difference of words from strategy 2 to strategy 1. Our statistic, significance level, hypothesis. We did our plan, named the procedure, checked our conditions. Those are all good. Did all of our work, got a p-value 0.001. So, assuming there is no difference. I'll move this thing if I can. I can't. All right. Okay. Get rid of that keyboard. Okay, so I just lost it. Assuming there's no difference between strategies, there is a 0.001 probability of getting a sample mean difference of 1.5 or more purely by chance. All right, I'm going to post this so you have it. Therefore, because our p-value is less than 0.05, we reject the null. So there is convincing evidence that the mean difference in strategies, the number of words they memorize, is greater than 1.5. So that tells us that strategy 2 is better than strategy 1. All right, let's see if I can get this back. I can't. Oh, there it goes. Hey, there I got it. All right. All right. Okay, so 0.001 goes here. Oops. And 0.001 goes here. All right, got it. Okay, there we go. Isn't this fun? All right, so our important ideas. We have a one sample t-test for the mean difference. And our value of t we find by doing x bar difference minus the mean difference divided by our standard deviation difference over the square root of n. All right, cool. And so the big thing is looking at, is this a one sample or a two sample t-test that you're looking for, or confidence interval? One sample to match pairs. That means we subtract the numbers, then we find an average. All right, there's only one mean in this case. All right, you have one group of people, one mean. You have two different data from that one group of people. If it's a two sample, you have two different groups, two different means. We find the average and then we subtract them. So x bar 1 minus x bar 2. All right. So to check your understanding, each of the following settings, decide whether you should use a two sample t. Procedures, you should use two sample t procedures to perform inference about difference in means, or a paired t procedure to perform inference about a mean difference. Explain your choice. So go ahead and do these three and pause the video, and I will then talk about each one real quick. and we'll be done with this one, and then I'll make a new video for just what we got to do left. All right. So here we're talking about scuba divers that are dealing with just one scuba diver, and they have two different flippers, one from each foot. So since it's just one scuba diver and we're recording two pieces of data from that one scuba diver, it's a matched pair T procedure. Number 2, or B, study the health of aquatic life. Scientists gather random samples, 60 white python in the Amazon River and 82 white piranha from the same a decade ago. So here we're talking about two different groups of piranhas. So that would be a 2 sample T. And then the last one with the wetsuits and the sharks. Once again, we're talking about, this is 2 8-hour time periods. So 2 different groups of 8-hour time periods with each type of drum. So once again, that's a 2 sample T. All right, so this is the last lesson. Do your homework for this. Send it to me. And then we will, I will set up a test for you later in the week for you to do. All right, and I'll talk more about that on my other video. Have a great day.